All right, good morning. Welcome back. Hope you guys are doing well, staying safe, staying dry, having a good start to your Wednesday. I'm looking for a few people. Looking for Alan, looking for Tristan and Irvin. If you're here, please let me know. Oh, Irvin's here. Never mind. Just mismarked you. Nidal should have been. Nidal, if you're here, let me know. Hi, Tristan. Welcome back. Please try and get here a couple minutes earlier. No, Nidal. So Nidal and Alan, if you're here, please let me know. You could unmute, say, hey, Mr. Brown, good morning. Or you can throw your name in the chat. All right, so welcome back. A lot has happened since the last time I seen you guys. Let's check out the COVID report for today. See where we stand as a county for COVID. See those numbers. Right now we have 471 active cases of COVID in the county. We have 19,317 resolved cases in the county. So if you remember, like a week or two ago, we were just about to 399 mark. We're close. We almost got down below 400, but last week or so, this number's been slowly increasing. Why? Because we're adding more and more cases each and every day. Number of deaths, if you remember a couple weeks ago, we were stuck at like 399. I was hoping we would get to 400. But the week before that, we had like a week of no deaths. And this week we've had several deaths throughout the duration of the week from complications of COVID. Number of people in the hospital system, 20 people in the hospital, 3 people in ICU. Those numbers are a lot better than what they were. They're decreasing. Vaccine numbers are increasing quickly. That's a good sign. Let's check out the number of daily positive cases. So what's happening the last few weeks is we're adding about 44, 40, 26, 33 cases, 44 cases. We're adding more and more cases, so when you keep having like 44, 40 cases per day, it's gonna take like 14 days for COVID to get out of the system. These numbers are just too high. We just gotta lower those numbers in order to get number of COVID cases in the county to decrease. Yes, we're steady here. That's a good sign. We're steady. But I'd be happier if we're steadier at a lower mark, like below 20, below 10. Like all summer we're, I guess you could say we're somewhat steady, below, for the most part, below 20 for the most part of the summer. June, we're below 40, below 30. Summer, if you remember, it was a crazy summer because we didn't know what was going to happen. But summer, for the most part, wasn't that bad. Hopefully we get to those numbers sooner rather than later. But there's the COVID numbers. There's a COVID report for today. No, COVID's still out there. It's still in the county. 471 people in the county have COVID. Be smart, be safe. Protect yourself, protect your loved ones. Wear a mask, social distance. Don't get in anybody's grill. Give them some space. Hey, Alan, welcome back. And you'll be safe. So welcome back. That's the first order of business. Next up, I had this up here as well. Last night there's a board meeting. Hopefully you or mom, dad, grandma, whoever's at home with you had a chance to watch the board meeting too. What happened in the board meeting? The superintendent kind of introduced it to you guys. I told you guys about it yesterday. The superintendent introduced and proposed implementation of 5 days per week for grades K through 6, middle school, and 11th and 12th grade. Sorry, guys. So on April 12th, the day after spring break, the Monday after spring break, K through 6, 7, 8, 11, and 12 will be coming back full time. You guys are in 10th grade. The whole class is in 10th grade. I guess that's okay for teaching aspect in this class. But I I know some of you guys probably want to get back, want to get out. They changed the plan from what they originally said. So that plan doesn't deal with cohorts anymore. Changes. It's only 11th and 12th graders, a full population, 11th and 12th graders will return back to Proctor on the 12th. Why did they do that? My guess, I don't know, they didn't say why they did it, or I might have missed it with my kids, but my guess is they want to give these juniors and seniors some experiences around Proctor. Give them a chance to get back in the building for their junior and senior year. Imagine being a senior in 12th grade, spending the last year virtually and not getting to be in the classroom at all, the school at all. So I don't know. Maybe they wanted juniors and seniors to get in the building, get familiar with it. Usually your juniors and seniors are a little bit more mature, and maybe they'll figure out the routine first and then bring you maybe the 9th and 10th graders. Obviously, there's almost 3,000 people here. So those numbers, hopefully they'll bring you guys back sooner rather than later. So they're going to iron out the kinks with 11th and 12th grade, and then hopefully they'll bring back students. So why the sudden change? I'm not completely positive, so I'm not sure about it. But I do know if your older brother, older sister, 11th or 12th grade, or younger brother, younger sister come back to school, a little heads up. If they take a bus, if you need to tell your parents this or whatever, feel free to, or they can watch the meeting, or I'm sure you'll get some information at home that you might have to read. If they're taking a bus, whatever grade you're in, you have to wear a mask. You have to wear a face shield instead as well. So a mask and a face shield is going to be required on the bus. So on the bus, you need mask, face shield. And within that, that's according to the CDC and New York State, Oneida County, they say that's safe enough for that extra barrier that you could sit by somebody that does not live with you. So that has changed. That's why there's more people that could be pushed on the bus. You'll be sitting with somebody if you come back to school on the bus. Once you get into the school, as of right now, from what I heard and understood from the meeting, once you get into school, whatever, if you're in K, if you're in 8th grade, whatever it is, K through 8 or 11th and 12th, once you get into school from the bus, that shield, that plastic shield could be put in your book bag. Throughout the duration of the day, you wear a mask all day, besides obviously eating. I don't know, maybe elementary does mask breaks, but I don't really know the details down there. So your mask has to be worn throughout the duration of the day. And then once you get back to school, in your classrooms, they now reduce the social distancing to 3 feet, not 6 feet anymore. Once you get to the classrooms, desk, plastic barrier. They'll have these like plastic barriers on your desk as well. So these plastic barriers, from what I understood from the meeting, are going to have 3 sides to it. And each desk will have its own plastic barrier there. So those will be on your desk. When you're sitting at your desk, you do not have to wear a shield, but you do have to wear a mask. So those are the requirements for that. Each desk in Proctor that has students there will have a barrier. That's crazy. It's a lot of barriers. But that's the situation. The desk will look like that. They're working on setting up my room right now. I would talk about my routine with half the population in school, half population at home, but you guys are in 10th grade, you're gonna be at home, so that's good. So we're not going to change your routine for this class, since we're all in 10th grade right now. You guys come back, we'll talk about a different routine. But another thing to note is if your mom, dad, grandma, you, or your older brother or sister do not feel comfortable coming back, then you can remain virtual throughout the duration of the year. That's good. So you have that option right now on whether or not to come back at the capacity. Lunches. At Proctor, lunches are still going to happen, and supposedly they bought these barriers that are for circular tables. So I found it earlier. So basically your tables in the cafeteria, circular. And then there's 4 barriers, kind of like that, where you obviously eat your lunch, hang out with your friends. You know, you can do like a high five through like the barrier, eventually, maybe. And eat your lunch there. So lunchrooms will be set up in that system. Elementary schools, you're taking your lunch, you're going back to your classrooms. Don't know what's going on in middle school. I didn't see any questions on the chat yet. Additionally, other things that are going to happen on April 19th. This is a big one probably for some of you guys. April 19th is going to be the beginning of athletics, spring athletics. Hey, we're back at it. Spring athletics are going to be happening, starting on April 19th. So the week after spring break, 19th, is when spring athletics are going to begin. What does that detail? That details JV and varsity softball and baseball, girls and boys track and field, I think lacrosse. I don't know if there's anything else missing. From what I understand, from what I got from the meeting last night, those are the sports. Maybe I'm missing one. Maybe I am. But sports will be rolled back out on the 19th. And since you guys are virtual, somebody asked, are they allowed to participate? Absolutely. You're allowed to participate. I'm happy to see sports coming back because you guys, if you're athletes, you probably miss that stuff. You probably miss getting out in the field and watching everybody else play. They talked about the musical. They're not sure what's going to happen with the musical or how that's going to be taking place. That's the
So,
gist.
Mr. Brown.
Hey. Yes.
So if 9th and 10th graders go back and some of them stay virtual, can they still participate in sports?
Yes. No matter if you're virtual or not, you can still participate in sports.
Thank you.
You're welcome. All right, some more questions. So all the elementary students, some questions people asked. So all the elementary students start going back all week. If your parents feel it's good, safe, whatever. I'm not telling you have to go back every day. I'm not telling you to. I'm not telling you not to. That's the decision between your family. All students will start to go back, yes. Elementary students have the ability to go back every day starting on April 12th. April 12th, they can go back 5 days a week, hopefully for the end of the year, till the end of the year. Hopefully that helps with that question. Another question. So if the transportation for the 11th and 12th grade goes well, then they will let 9th and 12th graders back. Oh, transition. I'm sorry, not transportation. Transition. Proctor has 2,700 students in the building. And still within the space of whatever surface area, the space or the room sizes of each of the Proctor rooms are, it still has to meet on paper 3 feet distance. If they cannot go 3 feet social distance with all the desks and how it's aligns, then they might have a problem with that. They want to bring 9th and 10th graders back, but they still have to work out the logistics of how to bring 9th and 10th graders back to Proctor. They didn't give too much information on the rollback of 9th and 10th. They'll work on it because they're very proactive at Utica. They're going to figure out how could they bring 9th and 10th graders back as long as numbers are okay. But they didn't give out any leads on that last night at the meeting. Someone said, do you think we're going to go back at all? Are sports back on? Sports are back on. We talked about that. I don't know, Frank. What I could see, maybe, is cohorts for 9th and 10th. Maybe. I don't know if we have the room for the full population back at Proctor. Maybe we do. But that's for someone higher than I. Another question. In class, you need just the face mask, and I will have a mask as well. So in class, I'll need to wear a face mask. There will be a plastic barrier around your desk. So you do not need the mask. There's a plastic barrier which is acting as a shield in the classroom. On the buses, you need the mask and the shield. Additionally, teachers' desks are going to have these big, I guess, plastic barriers around the teacher's desk as well. Once you get back, I'm not going to be scared of you. I don't think I'm not trying to hide behind a desk, but that's also there for the teachers too. Leo, I've been asking this. I want to go in the weight room. Are we allowed to be in the weight room? I don't know that question. Your coach might know that question a little bit more, or your gym teacher. No idea about that. Someone asked, are we allowed in the weight room? I don't know. Ask the gym teacher, ask the coach, they might have that one. Yes. 9th and 10th, someone asked, could 9th and 10th graders be in person for their extracurricular activities? If you're talking about the musical, I don't know how they're doing about the musical. They just talked about sports. They did talk about the musical a little bit. They said for Peter Pan musical, it's up to really the state or the county for indoor events, like concerts like that. So they have to get more guidance from them. They said in one way or another, the musical will happen. Whether it be each student comes down to the stage and does a performance, they record it, and then they put it all together virtually, or maybe they'll bring some people back in for that. Don't need a face shield. Oh. All right. Someone said we don't need a face shield for walking. If you're walkers to Proctor, I don't believe you're going to need a face shield at all. I don't know how they're going to be distributed, but I'm sure they'll address that as well. From what I understand, the face shields are only necessary for the buses. Beyond that, from what I understand, you don't need the shield anymore. You can walk in the school. As soon as you walk in, you put it in your backpack. You're not chopped liver. Not chopped liver. We care about you. It's just a big school. Okay. Sorry, folks. I think that's all the questions. Hopefully I answered some of your questions. I'm sorry that some of you guys that want to come in and want to get out of the house a little bit. I know that the plans have changed a few times, several times. We're going to have to keep rolling with it. I just keep relating what I hear, and I'm just trying to inform you what I know, just so you're not blindsided at the end. But maybe you were, maybe not. Really? My roster said they're representing 10th grade, but maybe not. I thought my whole roster was 10th. Oh, okay, cool. Never mind. So I do have some people that are in 11th grade. Cool. If you want to come back. So still, since there is a couple people in 11th grade and 26 of you guys are going to be virtual, I'm definitely not going to leave you guys out at home and say, hey, I have 2 students in class. I have to go just work on this assignment. I'll see you guys in 84 minutes. No, you know me. I'm not going to do that to you. Does anybody have any other questions before I start class or shift gears now for today? Can't wait to meet you. You all. All right. If you do have more questions, or if I find out more information about the return of 9th and 10th grade, which probably won't happen for a couple weeks, they're going to want the smooth transition between 11th and 12th first. And then they'll start talking about, should we bring back 9th and 10th? How are we going to bring back 9th and 10th? Once I find out details or hear of details, I will definitely inform you. If you have more questions, feel free to throw them in the chat. I'll try to get them. If it's like someone asks a really good question, and I can't overlook this question. Someone wants to know my thoughts on pineapple on pizza. It's a tough one. Personally, I probably wouldn't order it too often. I'm more of a traditional pizza guy. I love my pizza. There's not many pizza joints in Utica I don't like. Tomato pie, same way. Love my tomato pie. Roma's or Napoli's. I'm a Roma's guy. Rosario's or Parkway? Pizza box. Oof, good questions. Parkway. Parkway's good. A lot of good choices. Pineapple on pizza. If you're going for like a barbecue, like chicken pizza with pineapple, I'm all about that, Joe. Chicken wing pizza from Rosario's. It's pretty good. A few bucks, but it's pretty good. How about you, Joe? Anything about pineapple on pizza? It's like a Caribbean style or no comment. It's fine. Well, if you find a good pizza joint that I haven't explored or you really love, throw it in the chat so I can explore it too. I make my own pizza too as well. I used to work at pizzeria. I used to work at Subway over before they took that building down. I was an old, younger guy. Subway in East Utica. Worked at a pizzeria. Now I make a lot of my own pizza for my family. I make the dough. It's easy to do it. You save a lot of money. The dough, sauce, whatever. Good questions though. Very good questions. I'm glad I got to get to the pizza questions because now I'm like extremely hungry. Let's go. Here we go. All right, welcome back. Quote of the week comes from Les Brown. Shoot for the moon, and if you miss, you'll be among the stars. Set your bar high in life. Set those goals high. If you fall, you'll still be pretty high up there. You'll accomplish big things. Today is Wednesday, March 24th, 2021. Today's a day 2. Today we're going through Unit 8, Oxidation and Reduction, REDOX, specifically redox reactions. Before I get to the redox reactions, we're going to go through benchmark review. It's a warm-up. It's going to be on Unit 2, which is matter and energy. More specifically for review today is matter. We'll go through some guided notes, and then these examples we'll scratch until next class. Your quarter 3 benchmark will be March 30th. March 30th, your benchmark will be for quarter 3. It's going to have 30 multiple choice questions. And on the benchmark, you're going to have questions from Unit 2, Unit 6, Unit 7, matter and energy, properties of solutions, and kinetics and equilibrium. Very little on equilibrium as well. So 30 questions from those 3 units. I will start reviewing from here on out till the 30th for the benchmark. The first review is on matter. The second one will be on energy. And then I'll talk about properties of solution. I'll break that up into a couple days and probably just kinetics for another day. So those are the topics that will be on the benchmark. If you want to start reviewing, feel free to check out some review. You could obviously pull up your classwork. You can pull up all your guided notes, your exit passes, examples from the units. Right here, if you go to classwork, you could check out your table of contents. You have matter and energy, Unit 6, properties of solution, Unit 7, kinetics and equilibrium. So Unit 2, you could figure out what we did. You could figure out old assessments. I'm sure you could review your old assessments. You could check out the guided notes. Santino, if you want the guided notes, they're right there. You could check out the textbook if you want for review, and maybe some videos if there's a topic you want to see. And my guided notes that you guys completed here. Oh, let's see how Faith's notes looked from back in the day. So Faith has access to these notes as well. And oops, oh no. Oh, I don't think I started grading until the 3rd unit. So anyways, you can figure out exactly what happened or what we talked about with matter and energy. So you can pull up your notes. Obviously, you can't pull up everybody else's notes. You can only pull up your notes. That's one way to get it. Or you could go throughout the drive, which is the place where all your Google Docs are stored, the drive. And then you could just find your notes by searching the toolbar. Maybe Unit 2, matter and energy, you can type up there. Mine's organized with folders, a little bit different than yours. You could organize yours into folders. And Unit number 2 for our class looks like this. So again, what do we talk about in Unit 2? We talked about matter. We talked about mixtures. We talked about percent air and temperature. We talked about heat and energy. We talked about heating curve, cooling curves, ideal gases, vapor pressure, and density. So the focus of today is really going to be heating curves, cooling curves, and topic 1 and 2. But anyways, in this unit, we talked about mass, talked about basic measurements, easy stuff there. We talked about phases, solid, liquid, gases. We should know what they look like. We should know properties of solid, liquid, gases. Started this on like September 29th, and it took us like forever to figure out how to draw these little circles. It took us forever to figure out how to color this stuff and make it look nice. But now we're like professionals. You could do this stuff pretty quickly. You could draw a diagram pretty quickly. Myself too. You should know physical and chemical properties of a mixture or a substance. You should know if mixtures are going to be homogeneous or heterogeneous. You should know different ways to separate mixtures. Filtration separated by different phases, maybe a heterogeneous mixture. Distillation separated by liquids with different boiling points. You heat them up, liquids separate in different capacities. Chromatography we talked about earlier in the year about an element. You know a heck of a lot more about an element than just that definition now. We know compounds. This is when we introduce an element and compounds. And we should know about different types of reactions. We'll actually talk about this stuff a little bit later in class today. Chemical reactions, there's synthesis, addition. Two things come together. Decomposition, decomposing, a compound breaks up to two smaller things. Single replacement is like substitution, or double replacement is a compound plus a compound yields a new compound plus another new compound. We talked about elements. We talked about a reactant and product. We talked about a forward reaction way back in the day. We talked about conservation of mass. So whatever the mass was on the left side has to equal the mass on the right side. We talked about percent error, did some examples. If you need some examples to check out again, check them out in your notes. We also talked about temperature conversion. We know temperature is the average kinetic energy of particles. We know temperature conversion for Kelvin and Celsius. You don't need Fahrenheit. We talked about heat of fusion, heat of vaporization, kinetic energy, potential energy, heat of specific heat capacity as well. These examples we'll explore again next class. We'll review heat next class. We also talked about heating curves, cooling curves. This took us forever to make too. Heating curves with terminology, heating curve with energy. We talked about cooling curve with phases, cooling curve with energy. And last but not least, we talked about these little happy little gases. We talked about ideal gases. Ideal gas, high temp, low pressure. We talked about them in terms of PVT, ideal gas laws, combined gas laws. And again, next class we'll talk about those examples too for review. And today we'll talk about vapor pressure. Vapor pressure is the boiling point at specific vapors or pressures. This portion of the curve will be on today's assessment. We talked about intermolecular force, attraction between particles. The higher the boiling point, the greater the intermolecular attraction. We'll talk about those as well. So I'm going to ask that you open up your warm-up for today. Warm-up today is going to be on matter and energy. Let me pop this open. Maybe you want to use your notes to assist you. But warm-up today, unit number 2, is on matter and energy. The first day for review for the benchmark 3 starts right now. There's 10 questions on basically matter, heating curves, and vapor pressure. That's the main topics for today's warm-up. I'm going to give you 10 minutes to work on this right now. Then after 10 minutes, we will go through these questions. At 12:22, we'll break out of the breakout rooms, and we will go through these questions. So again, please work on the warm-up. Warm-up today is going to be on benchmark review, unit 2, heating curves, cooling curves, vapor pressure. Last, please join your breakout room. Please attempt these questions. If you have questions, feel free to ask for help. Again, please join your breakout rooms. At 12:22, we will review these. Please try them out. Give it a shot. Please join the breakout rooms. Please attempt these questions. If you have questions, you don't understand it, ask for help. 1222, we will review these. No problem, Joe. If you have questions, let me know. Please work on the warm-up till 12:22. Oh, excuse me. Excuse me. Okay, 30 seconds, everybody. We'll be back. session. All right, we're all back here. Let's go through these questions. Let's see how we did with this warm up on unit number 2. Question number 1 says, which equation indicates a process of crystallization? Crystallization is going to be a process going from right there, crystallization, going from a liquid to a solid. So you're looking for something that's going to end with solid. The only thing that ends with solid, it's got to be choice D. So aqueous, it's kind of like a liquid. It's a mixture of a liquid to a solid. One of the best answers is going to be choice D. Number 2, talking about energy required to change the unit mass of a solid to a liquid. So again, solid to liquid at constant temperature is called what? Please record your answer in the chat. Number 2. 4 for 4, 5 for 5. Thank you. 7 for 7. Choice D is the best answer. Heat of fusion from a solid to a liquid. Solid to liquid. If you look below, solid to liquid, that transition right there, that's heat of fusion. Heat of vaporization goes from a liquid to gas. Formation, we didn't talk about. Combustion is when you burn something and the products are carbon dioxide and water. We did that Wishbone experiment for combustion to help you think of that one. Number 3, I do want to talk about number 3. Let's check it out. Standard pressure, a 1 molar solution of sugar has a boiling point of what? Is it greater than or less than 100 degrees? So in this situation, I would think about water. Start off analyzing water, and you should be aware of the boiling point and the freezing point for water. So let's make a little chart here. So water, and it has a boiling point, BP, in degrees Celsius, and a freezing point in degrees Celsius. I don't care about Fahrenheit. We'll talk about, just save a reference, but I'm not too concerned with Fahrenheit. Water has a boiling point. If you ever try this at home, water has a boiling point of 100 degrees Celsius. Water will boil at 100 degrees Celsius or 212 degrees Fahrenheit. Care about degrees Celsius. So water has a boiling point. Water will boil at 100 degrees Celsius. Water will freeze at 0 degrees Celsius or 32 degrees Fahrenheit. I care about Celsius temperature. What happens if you put some sugar in some water? If I take a beaker, nice yellow beaker, so I didn't wash it, it's dirty, and I put some water in there. If I, oops, throw some water in there. Shh. All right, turn the water off. I throw some sugar in there now. If I throw some sugar particles in there, that is now going to change the chemical composition of the liquid. What's going to happen, these sugar particles are going to dissolve in the mixture, and it's going to change its chemical characteristics of the liquid. The chemical and the physical properties of the liquids change now as well. So what happens in the situation is the sugar, or a lot of times they say salt. What happens is these particles are going to start to dissolve, dissociate, and it's going to change the boiling point of the water. As you have this mixture, you heat it on up, it's going to take more energy to separate these molecules, and it's going to have a greater boiling point. So when you have the boiling point of a sugar solution, it's going to be changed. What's changed? The boiling point and the freezing point. So with sugar or salt, KCl, NaCl, whatever they're talking about, the boiling point will be different now. Sugar solution. If you ever made candy, if you ever made like any hard, sweet candy with making sugar or caramel at home, you'll notice that sugar has a high boiling point. Peanut brittle, that's going to have a high boiling point. A lot greater than water would be. So sugar solution, dissolve sugar and water together, the boiling point of the sugar solution is going to be greater than 100 degrees Celsius. Definitely greater than 100. The freezing point is going to be less than 100, less than 0, not 100. Less than 0 degrees Celsius. So best answer here, greater than 100. Freezing point less than 0. Number 3, the best answer is choice B. 3 is B. Next up, number 4. What happens with a sublimation? What happens in sublimation? Sublimation, please record your answer in the chat. Thank you. Thanks for responses, guys. Sublimation is a long word. It starts with an S. It's a big transition. I told you that earlier in the year. Sublimation starts with an S, solid. It's a big jump to the next phase. Starts with solid. Not C, it's not D. It's a big jump, solid to gas. You guys know that. Choice B is the best answer for number 4. Number 5. Student collected data in an experiment in which the uniform cooling of water sample was observed from 50 degrees Celsius to negative 32 degrees Celsius. Which graph most likely represents the result obtained by the student? We know it's going from 50 to 32. 50 to 32. First part I would say is it's decreasing. You know 50 to 32, it's got to be decreasing. Choice C is increasing. Choice A is increasing. Just like that, by analyzing those two numbers, we have a better chance to get this right. All right, let's analyze some more stuff here. It's talking about water. Water, just like the last 2 examples ago. Let's talk about water again. Who knew you'd know this much about water by the end of the year? All right, water, we have 50 degrees Celsius and negative 32. Let me mark these little intervals. I'll make a little scale here. And 50, it's probably gonna be right, it's gonna be right in the middle. So we'll pretend this is a scale. And the other value is negative 32, which is gonna be below. So 2 blue lines are from the data points. What else should we know here? We should know from 0, let's go down here. Below 0 degrees Celsius, anything below 0 or below, that water is going to be a solid. Less than 0 degrees is a solid. We should know that within the range from 0 to 100, 0 to 100, it's going to be a liquid. And then we should also know greater than 100, it's going to be a gas. This question is talking about 50 to negative 32. So I only care about the portion of this chart from here. You can follow all that. We know that it's got to be a heating curve. I'm sorry, it's got to have the X and the Y axis. It's got to have time. It's got to have temperature. Temp there as well. It's starting off at 50. It goes through a transition from liquid to solid. It's going to freeze, crystallize, and then it's going to form a solid. Choice B is the best answer for number 5. 5 is B. If it didn't have a transition, so if it said from 0 to negative 32, it's all going to be a solid. That would be the choice if it said from 0 to negative 32. It's just analyzing that portion of the curve. But you do have a phase change there. That's why that is represented. 5 best answers B. Next up, number 6, another curve here. The accompanying graph represents a heating curve of a substance that starts with the solid below its freezing point. What's the melting point of the substance? Please put the answer in the chat. What is the melting point of the substance? Easier question here. You could analyze this graph and say, hey, it's a heating curve, solid, liquid, gas. Oh, from solid to liquid, this is my melting point. Find that portion of the curve. Yeah, choice B is the best answer for number 6. 6 is B. Number 7, try this one out. Which graph best represents a variation of a vapor pressure of water as temperature changes? Which one represents vapor pressure of water? Please record your answer in the chat. I had all 3 classes today, and all 3 of my classes surprised me. I think everybody get this question right. Everybody submitted an answer for this one. Got it right. Vapor pressure of water. Where do you find vapor pressure? You find it on like the 4th page of the reference table. Right here. It's in your notes too. Let me open up my reference table. Page 4 of your reference table. You have this curve. You highlight water. Again, more water. It's that kind of blue curve. Vapor pressure, temp. Which one's most similar to that? Obviously, choice C. Nice job. Vapor pressure. There's like 4 questions on vapor pressure on the benchmark. Whoever made the exam went crazy with vapor pressure. I don't think there's any questions on Le Chatelier's. Some other teachers didn't teach Le Chatelier's, but you guys know about Le Chatelier's principle. There'll be like 1 question on equilibrium. I know that. Number 8, the accompanying graph shows the relationship between vapor pressure and the temperature for substance X. What's the normal boiling point for substance X? What do you think the best answer is for number 8? Very difficult question for a lot of students that I already had. Is it difficult for you? Got a lot of this going on there. It's a tough question. You guys are like, oh, what are you talking about, Mr. Brown? This is vapor pressure. This is vapor pressure. I have ATMs on one side and I have KPA on one side. You're like, what the heck just happened there? Normal boiling point. When you think of normal boiling point, those are conditions here on Earth. When I see normal boiling point, you should be thinking of standard temperature and pressure, STP. Normal boiling point, hopefully it triggers that connection. Hopefully you think of STP, you think of page 1 of the reference table, the first chart. Hopefully with normal boiling point, you think of STP. Hopefully think of page 1 of the reference table, see standard pressure, standard temperature and pressure. It's not KPA, no, it's atmospheres. So that 1 atmosphere is going to be the reference point on that curve. So that's standard pressure for atmospheres. Match that up at this point of intersection, that's where it's going to boil. So at this point right there, that is the boiling point of the substance. Had a few of you guys get this right. 30 degrees Celsius is a normal boiling point for this substance. They will only give you a question on KPA or atmospheres for pressure. There's something called torr, which they won't give that to you unless they tell you standard pressure. This one, you can just click this. Don't worry about it, I'm not going to grade it. Next up, number 9, use your knowledge of chemistry and information on table H. Which statement concerning propanone and water at 50 degrees Celsius is true? So this question, we're comparing propanone and water. This chart, let's go through this chart a little bit more. We don't know anything about propanone yet or what it is. You will in unit number 10. We don't know ethanol. We know a lot about water. Hopefully you know what that is. polar covalent bond. And ethanoic acid, we'll know what that is in unit number 10 as well. So what are we highlighting here? We're highlighting propanone and water. Hopefully you have access to your Chromebook and your reference table. Hopefully you figured out a way you could draw on your reference table. If not, you have a hard copy in front of you as well. But you can only draw on that so many times before you need a new one. And there's your propanone as well. So propanone, water, we also have a value of 50 degrees Celsius. Mark up 50 degrees Celsius. That's the first step I would do. And then I would analyze, I was talking about vapor pressure. It says high or low vapor pressure. So the first thing I check out is my vapor pressure for each. That's on the y-axis. There's vapor pressure for propanone. And roughly there's my vapor pressure for water at that temperature. What's the best answer for number 9? 9's best answer, please put in the chat. Cool. Very consistent. Thank you, guys. I really wish if I had any classes to take the Regents, I wish this class right here would take the Regents. I know you guys would do well. But here we go. Moving on forward. Maybe next year. Maybe next year. Maybe next year you say, hey, I want to take that Regent to see if I actually learned something in Mr. Brown's class. I wouldn't recommend it because you're going to have a whole year not seeing chemistry. Maybe you'll take AP chemistry next year. But what are you going to do? All right, back to this. There's a vapor pressure for propanone, vapor pressure for water. Best answer here is going to be choice B. Propanone has a higher vapor pressure, and with that, it's going to have weaker intermolecular forces. Weaker attraction for molecules. It's not going to be held together too tightly. So how did I figure that out? I would have figured out, hey, that propanone and water at 101.3, you would have said, hey, propanone has a lower boiling point than water. The higher the boiling point, the greater the boiling point, the greater the intermolecular force. The lower the boiling point, the weaker the intermolecular force. Best answer for that is letter B. And number 10. Easiest question on this topic, I think. What's the boiling point of ethanoic acid at 80 kPa? Find 80 kPa. Find ethanoic acid. Ethanoic acid. He wants to know the boiling point. This question, mark the intersection point. Where does it intersect? Looks like 110, 111. So choice C is the best answer for number 10. Again, for this assignment, you could go through, you could submit it, but it's probably going to mark that one question wrong. It doesn't have an answer. I'm not grading it. This is a review. If you need to check out more of this information, please feel free to check out your guided notes. That's the good thing about this course. You can easily pull up your examples. You can easily pull up your exit passes to get more understanding or try to clarify what you learned earlier throughout the year. So it's not a bad thing. You have a nice digital copy of what we did in chemistry. A lot more organized than maybe a notebook would be. All right, we're done with that warm-up. Finally, all set with that review. Next review will be on heat and ideal gases. Again, that's not going to be graded. Moving on forward to guided notes. Topic number 2, please open up your guided notes. We'll pick up where we left off last time. All right, back at this. Please open up your guided notes. We're on topic number 2 now. So last few classes, we spent so much time talking about oxidation numbers. 3 classes talking about basic ideas, the rules for oxidation numbers. We know Leo says GR. Loss of electrons is oxidation, gain of electrons is reduction. We know about that. We know about the rules. I told you memorize the rules. The quicker you memorize the rules, the easier this unit will be. You'll see why in a couple minutes. So you memorize these rules, and you figured out how to come up with oxidation numbers for a compound. I spent a lot of time color coding. I said, hey, number of atoms of K times the oxidation number of K plus number of atoms of Cl times the oxidation number of Cl. And I said, hey, it equals 0 because rule number 7. These rules had to come into play. Hopefully you memorize these rules. Spent a lot of time going through those 3 examples, and we had other examples that we analyzed too, which were on Google Forms. If you didn't understand how to do this portion, or I said, hey, who has questions of where these values came from? If you didn't understand how to do that, you may want to watch last class, because today is going to get cray-cray. Just a little warning. I've been telling you, if you don't memorize the rules, this unit is going to be tough for you. If you memorize them, this unit is going to be a breeze. Promise you. Here we go. Moving on forward, we're talking about topic number 2, which is redox reactions. So redox reactions, oxidation and reduction reactions. Not all reactions are going to be redox reactions. So what we're going to do in this unit topic is going to analyze and figure out what is a redox reaction, what is not. We want to identify redox reactions. To determine if a chemical reaction is redox or not, the first thing you want to do is assign your oxidation numbers. So step 1, you're going to have to assign oxidation numbers. And you assign oxidation numbers for all elements on both sides of the equation, the reactant and the product side. So like down below, you're going to have to assign all the oxidation numbers for every element in the compound or the equation. Assign oxidation number for all the elements on both the reactant and the product side. Next step, if there's a change in oxidation numbers, then the reaction is going to be a redox reaction. If oxidation numbers for an element change from the reactant to the product side, if there's a difference in oxidation numbers from reactant to product side, it is going to be a redox reaction. What does that mean? Something was reduced, something was oxidized. What's that mean? Leo, loss of electrons, something lost electrons, and something gained electrons. If you walk down the parkway, go for a jog down the parkway, and you're rolling with $100 in your pocket, and the wind takes $100 out of your pocket, if you lose $100, someone's going to pick it up. Redox reaction. If something loses electrons, something's going to gain the electrons. Leo says Gur. Recognizing a redox reaction. In a redox reaction, if an uncombined element, if an element's uncombined, appears on one side of the equation, and is in a different form, or is in a compound. So if it's alone on one side, and then on the other side it's going to be in a compound, is in a compound, on the other side, the reaction must be a redox reaction. Why? The oxidation numbers will change. So it will be a redox reaction if the oxidation numbers change. If it goes from an element on one side and then a compound on the other, the oxidation numbers will change. Atoms equal 0. It's not going to equal 0 over here. we talked about different types of reactions. We talked about a synthesis reaction. We talked about addition reaction, synthesis addition, same type of reaction. You don't have to put this again if you don't need to. I'm going to put it again just to make those connections. So addition reaction equals A plus B, cap box, yields AB. They're combining. That's the same thing as addition or synthesis reaction. Decomposition reaction, you know these already. You don't have to put it down again. Decomposition reaction, AB yields A, decomposes down to two smaller things, A plus B. And single replacement or substitution, it's the same thing. It's going to have a formula like A, an element, plus a compound, plus BC, yields maybe a new element, plus a new compound's formed. In all these situations, there's an element on one side, and then it joins in a compound on the other. Element on one side, compound in the other. Element, oops, AB. Elements on one side, compound in the other. Those equations would represent a redox reaction. Why? Because oxidation numbers have changed. A double replacement reaction are not redox. My oxidation numbers will not change in the double replacement reaction. So double replacement reactions are not redox. Let's check out an example. For example, the first one's redox. Yes, we know because it's single replacement or substitution. An element plus a compound yields a new element by itself plus a new compound. Elements plus compound, element plus new compound. The second one is not going to be redox because you have a compound, a fixed ratio of two or more elements, plus another compound, fixed ratio of two or more elements, yields a new compound plus another new compound. So 4 compounds altogether in the equation. That's a double replacement reaction. Just a little heads up, from this point forward, there is not going to be any more reverse reaction. All the equations you're going to see from here on out for the rest of the year are going to be forward reactions. So it's no more equilibrium, no more Le Chatelier's principle for the rest of the year. Everything is going in one direction. They're all forward reactions from here on out. We only needed the forward and reverse reaction for Le Chatelier or equilibrium. So let's check out this equation. I'm going to break it up. I'm going to highlight it. I'm going to highlight each component of the equation. I'm liking these features of like color coding so you can really figure out where these values came from. All right, so what we're gonna have to do here to figure out if it's a redox reaction, we're gonna do this a few times, just a couple times to really understand a redox reaction or the transfer of electrons. Yes, you could look at the chemical equation and say, hey, that is a substitution or single replacement reaction. That's a redox. Sometimes they might ask you like, which one of these equations are a redox? You could do You can do that. You can look at, say, hey, which one's single replacement? That's redox. That's not double replacement. Sometimes they're going to ask you which one loses the electrons, which one gains the electrons. Or they'll ask you, what's the oxidation number of Cl in HCl? What's the oxidation change for Cl, they might ask. So in that situation, you're going to have to assign oxidation numbers. Above, it says the first step to figure out if it's a redox reaction, assign oxidation numbers to all elements in the compound. This is the reason why I really took the time the last 3 classes to assign oxidation numbers. Now we have to do that for every element in the compound. Let's do that. All right, first up, I'm not going to write it out as thoroughly as I did last time. I'm just going to put parentheses to identify what's it's referring to. I'll talk about it, but I'm not going to keep writing it out as much. All right, so first up would be number of atoms of Zn. How about hold up here for a second. This is by itself. This one's by itself. That's an atom all by itself. What's the oxidation number of an atom? Anybody? An atom's oxidation number is equal to? Rule number 1, atom's oxidation number equals 0. So I just hit control period 0. Good. Rule 1, an atom's oxidation number equals 0. That is an atom, it's by itself. Rule number 1, atom's oxidation number equals 0. In this situation, that's an atom, it's by itself, or a monatomic ion is considered by itself. If it's bonded with itself, or an atom by itself, its oxidation number is 0. That's rule 1. Atoms are 0 because protons and electrons are equal. All right, that's 0. This is a monatomic, bonded with itself, ion. This is equal to 0, 2. Atoms equal 0. Rule 1. Easy. But now we have to solve for the oxidation number for H and Cl. So next up, my color code is green. Make my font smaller. And I'm going to ask how many H's are present there? And you'd say, hey, there's 1. That's easy. Yes. And then I would say, what is the charge on H? Oxidation number for H, I'd say. And you'd be like, ooh. Maybe you memorize the rule. Maybe you need to pull out the reference table, look at H and Cl. Check out the periodic table. H is there, Cl is over here. Oh, so H is by itself. Cl is a nonmetal, we know. Hopefully you remember that the charge of nonmetals. Nonmetals charges are over to the right. Nonmetals typically have a charge of negative, negative, negative. These guys have a negative charge, nonmetals. If they're negative nonmetals, H, in order to bond with it, is going to have to be a positive. So H is positive, nonmetal is going to have to be a negative. That positive negative attraction is going to make these two come together. That attracts those two. Vice versa, metals are positive, charges, they're all positive. H would have to be negative to bond with it. A positive and a negative attract each other. That's a rule. So again, H, there's a rule for that. You memorize that rule. You don't think about that process as often. H is +1 when bonded with a nonmetal. Rule 5. Oh, so H is going to be +1. H is +1. Plus, the second part of the compound is Cl. How many Cl's are there? There's 1. The charge of Cl, it's a halogen. It's in group 17. Halogen, group 17. Check it out for a second. Maybe you memorize the rule. Group 17, the typical charge is -1. It's a rule. it's not a bad idea to copy those rules down and put them right by you when you work on these questions. Cl is -1. And the whole thing has a sum equal to rule number 7. It all equals 0. Does this math work out? Yes, it does. 1 plus -1 equals 0. Those have to be the oxidation numbers. So I'm going back to the compound above. I'm going to hit in between H and Cl, H and C, hit control period. The charge on H is +1. The charge on Cl is control period -1. You put +1, you put -1, or just the plus or the negative. So we solve those oxidation numbers. Don't know what I did there. Super simple. Let's try to get through the Zn before class ends. Zn, go through the same process that we just did there. So analyze Zn, Cl2. How many Zns are present? We have 1. What is the charge on Zn? So my next step would check out the reference table, look at Zn. Is there a rule for Zn? No, it's a transition metal. But you can look at that and say, hey, Zn has 1 charge of +2. It's probably going to be +2, but I just want to make sure, let's solve to make sure it's going to be +2. So call that x. So 1 times x, because there's no rule for it, plus how many Cls? 2, times the charge of Cl. It's a halogen. It's in group 17. It wants to gain 1 electron. Equals -1. That's a rule. And it all equals 0. Solve for x. So solve for x. You guys could do that. I know you could do that. I hope you could do that. X plus -2 equals 0. Get x alone, add 2 to both sides. X equals +2. All right. Wasn't hard to do that one. So solve for the expression. I'm going to press enter. I'm going to put my work below. I'm just going to say x equals +2. What does that mean? That means the charges are going to be assigned. So Zn has a charge of control period +2. And Cl is going to have a charge of control period, brings it on up, of -1. You could put a space between them if you want. Those are the charges. And the last thing you're going to have to do is compare both the reactant and the peroxide of the equation of each element. So what does that mean? You're going to check out each element here. You're going to check out Zn. Zn goes from Zn control period 0. Control period brings it on down again. Yields Zn, and the peroxide is going to be +2. I guess I shouldn't color code now. So Zn goes from 0 to +2. The next element H goes from H +1 to H 0. So those changed. And last but not least, Cl. Analyze Cl from the reactant to the peroxide. You can check out Cl goes from Cl -1 to Cl -1. So it's definitely critical you guys memorize these rules because it's going to make this process a lot easier to look at. to understand. Once you have that, that's going to be for notes, but I'm going to say once you have that, then you can analyze and say, oh, Zn goes from 0 to plus 2. 0 to plus 2. Oxidation number has changed there. Let's check out the next thing. H goes from plus 1 to 0, plus 1 to 0. Those oxidation numbers have changed, so that's important. And then Cl, they're really not important because, oops, Cl's oxidation numbers did not change. They go from -1 to -1. So this guy really is not important to us. What's important? Zn changed. It lost electrons from 0 to plus 2. How does it get to plus 2? You're losing electrons. We'll get this next time. And H had to gain the electrons. So this is going to be the GER. So this guy lost the $100. H gained them. And we'll monitor all that stuff. We'll follow the flow of that stuff moving on forward. All right, guys, that's it for today's class. If you have any questions, feel free to hang out. I'll definitely address them and try to help you out with those questions. But that's it for today. We'll continue on this process next time. Have a good day. Make good decisions. Stay safe. See you guys. Bye. Hi, Nadina. Have a good day. Bye, Kai. Have a good one.
See you, Mr.
See you, Frank. Have a good one.
You too.
Thanks. Have a good day, guys.